Hello, this is Mackenzie Fallow and I will be presenting my project of physical science in ballet. I will be using a PowerPoint as my visual aid, so I'll be using that as I go. For slide 2 is my introduction. Not everyone knows that ballet is largely based on physical science, and this is presented in many dance films or television shows that are for the public to see. One major film that displays physics elements in ballet technique is The Black Swan. For slide 3, I talk about a little bit of the background. The movie came out in 2010, and there's multiple scenes in the movie where the physical science is brought to life, including the last scene and the Black Swan scene where she's dancing. For slide 4, the 3 topics of physics science movements in the movie are center of balance and gravity, rotational mechanics, and projectile motion. Slide 5 is the importance of balance and gravity in ballet. Dance is a combination of body movements with motionless poses. A pose is the balance of the body over a small area on the floor. State of balance is obtained only if the center of gravity is a vertical line passing through the support of the floor. Vertical force of gravity downward will be balanced by the force upward from the floor to the dancer's foot, also known as normal force. Newton's third law of motion, which is the action-reaction law, according to Sheila Dodge, states whenever one body exerts a force on a second body, the second body exerts an oppositely directed force of equal magnitude on the first body. A true balanced state is seldom accomplished by a dancer, but if the center of gravity is close enough to the balanced area, the dancer will appear to be balanced. Slide 6, the role of rotational mechanics in a pirouette. A pirouette is a very well-loved and common dance turn. To execute this turn, a dancer supports herself on one leg while the other leg is in retire. A preparation position is required, followed by a torque against the floor. The torque causes angular acceleration that produces the turning motion. Elaborating on the physics of torque, which is the twisting force causing rotation, one must account for the dancer's moment of inertia and how it is dependent on the body mass and distribution relative to the axis of rotation. If the body of mass is far from the axis of rotation, then the body of mass will have a larger moment of inertia. Slide 7, the execution of projectile motion in ballet. Dance jumps involve vertical acceleration and forces. Since gravity acts vertically downward on our bodies, we can remain motionless only if there's a vertical supporting force equal to our weight. Jumping off the ground requires a force downward against the floor greater than our weight. In order to execute a jump, a dancer must bend their knees in plie position in order to build up enough force. The height of the jump is the downward vertical distance through the force that is exerted. When a dancer's body loses contact with the floor, the center of gravity will follow a parabolic trajectory that is determined by the initial conditions starting on the floor. Slide 8, which is my conclusion. To conclude, one may view a real-life example of concepts of physics embodied in the artistry of dance in the movie Black Swan. The physical requirements and intensity of training is a realistic situation that a dancer would endure. In the movie, the main character, Nina, demonstrates all the physical science concepts discussed in my presentation. Thank you.